Our C2 Chapter 2 checkpoint assessment. We're now looking at slides 4, 5 and 6. First one, we're comparing chromatography and evaporation. We're trying to work out which one is appropriate for which situations. In the case of copper sulfate crystals from copper sulfate solution, well, we assume here that the copper sulfate crystals have been dissolved into the solution, and therefore we would get them out by heating. We'd evaporate out the fluid part and be left with our copper sulfate crystals, which are the solute in this case, and therefore we'd use evaporation. We use the same technique for salt from salty water. We add heat to the solution, allowing the water molecules to escape, leaving behind the solute, which in this case is salt. Chromatography is a very well-known experiment, is one that we use to separate the different coloured dyes in a felt tip pen. So for example, black will separate out into various different colours, orange will separate into different colours, and so on. We can also do the same thing for different coloured substances in leaves. Those are pigments in our leaves, which uses the chromatography paper and a solution, a solvent, which allows them to travel up the chromatography paper to produce a chromatogram. We've now got a solid substance in a test tube. We're heating the substance and recording the temperature. Let's have a look at the graph. We're getting a nice graph where the temperature goes up and a flat line and then goes up again. Let's have a look at the sentences. At first, the temperature of the substance, it is increasing because you can see here the temperature increases. Here we go. Then the temperature stays the same. We'll look at this again just to be clear. We've got this nice flat spot at 45 degrees. Okay, it stays the same for 3 minutes, 45 degrees for 3 minutes. What's happening here is we're going from a solid to a liquid, and so therefore this is the melting point of the substance. For the last 5 minutes, and again we'll just check, last 5 minutes, 1, 2, 3, 4, this is our stage here. Again, the temperature is increasing again, but the substance is now in the liquid state. Now what this graph shows is that the substance is pure. And what does that mean? Well, when we have a nice heating graph like this and it levels off that flat line, that means we've got a pure substance. If the line is not flat, then that implies an impure substance. Okay, we're going to be using all our sol words to do this first. We're looking at the maximum mass of a substance that can dissolve in 100 grams. That is the solubility. Oops. Okay, I'll come to correct that again. We've got one down. If a substance does not dissolve in water, it is insoluble. Get rid of the letter U here. 3 across. When the sugar dissolves in water, the sugar is the solute. And similarly, when salt dissolves in water, the water is the solvent. If a substance dissolves in water, it is soluble in the water. And when we dissolve salts in water, it makes a solution. That's salt water solution.